The last couple of problems we have are called complex fractions. Complex fractions are when you have fractions within fractions. So notice over here we have a fraction in the numerator and in the denominator. So what we want to do for these is we want to get them easier. Now, before we do this, I want to remind you of something. When we were trying to get common denominators, I don't even remember what problem was that we used. Well, I'll just make up a new one. Okay, let's say we were doing this and we said, oh yeah, we wanted a common denominator of 10. That's going to be our goal. And we said, oh yeah, we can multiply the top and bottom by 2 and turn that into 4/10. Okay, we are allowed to do that. We are allowed to multiply a fraction, top and bottom, by the same thing because 2 divided by 2 is 1. So this is the same thing as just multiplying the fraction by 1. It's just a special type of 1. So we're going to apply that same idea. In this number 5, what I would like to do is I would like to get rid of the fraction in the numerator. So what I want to do is I want to multiply by x. Now, if I multiply by x on top, I have to multiply by x on the bottom. Okay? Now, let's erase this because we're going to need space. Now, that is going to get rid of the x on top, but that's not going to do anything in the bottom. Notice in the denominator, I've got a y in the denominator. So what I'd also like to do is multiply by y, and I'm going to do that on the top and bottom. So let me show you what happens here. When we distribute this, we have in the numerator xy plus, and when I distribute here, the x's cancel. So I just get xy plus y. In the denominator, let me switch colors so you can see this. I'm distributing xy times 1 minus, and when I distribute here, the y's cancel. So minus x squared. All right, we may want to go one step further. We have a GCF on top, so we can factor out the y. That leaves us with x plus 1. And in the denominator, our GCF is x, which leaves us with y minus x. And that's it. We can't do anything else with this, but this is a little bit simpler because there's not a fraction over a fraction. So it's a little easier to work with. All right, let's check out the next one. We want to do the same thing here. I do not want to have that fraction over a fraction. So to get rid of both of those fractions, I'm going to multiply by CD, top and bottom. Okay, so when I multiply here, the d's cancel, and I'm just going to have c squared minus, and when I multiply here, the c's cancel, and I'm going to have d squared. In the denominator, I'm going to distribute here. The c's will cancel, and that's going to leave me with d squared. And when I multiply here, nothing cancels, so it's just 2cd. This is a fine answer. This works. You could factor a little bit if you wanted to. The top is a difference of squares, so you could factor that into c plus d, c minus d. And then the denominator has a GCF of d, so we get d plus 2c. Nothing cancels out of that, so I don't know if it's really worth factoring. Our first answer might have been fine.